ba 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 director. Man, what am I doing? Hold me now. I'm 6 feet from the edge and I'm thinking. Oh, hi. Didn't see you guys there. Welcome back to another exciting video of Mr. Bell Physics, where today we're going to be talking about the metric system. I wanted to make a quick video on this because a few of my students had a few questions about it, and the metric system is one of the most important things in all of science to be able to understand, to make sure you're doing your math right. So, we're going to spend a few minutes just talking about what the metric system is, how we use the language and how we can understand what it means, and then also how to convert from one unit to another unit to make sure that we're doing our math correctly. So, the metric system is the system of measurement that the majority of the world uses. Me being an American, we don't usually use it here. The only time that we really use the metric system here in America is for the science classes or for high-level engineering and things of that nature. Indeed, what the heck is a kilometer? Today we're going to learn. The metric system uses various base units to talk about anything that you really need to talk about. For example, the base unit of a length of distance is a meter. The base unit to describe something's mass is a gram. And this goes from everything from very common stuff like temperature, which is usually done in Kelvin or maybe Celsius, depending on what scale you use. But it's also for other more specific things. Things like electrical current measured in amps, or the brightness of light measured in a candela. All of these things use the same system, right? Even, for example, something that you're probably more familiar with than you think, digital storage. The standard unit is a byte. So things like megabytes, gigabytes, terabytes are all different forms of measurement relating to that through the metric system. The beauty of the metric system is in the fact that we have prefixes. Now, we have two sets of prefixes. Oop, drop my marker. We have two sets of prefixes. Prefixes that make a number bigger and prefixes that make a number smaller. Let's go through some of the more important ones for both. Let's start off with smaller. And for this, I'll use a blue marker. So we start off at 1. And the nice thing about the metric system is that we're always working in some unit of 10. So we always are getting 10 times bigger or 10 times smaller as we go down the list. So for smaller, okay, so we start off at 1, which I'll do in black. As we go this way, our first prefix is deci. D-E-C-I. So, for example, a decimeter or a decigram. This is 1/10. So 1 over 10. Meaning that there's 10 of these for every one of our base unit. Next up, we have centi. This one you've probably heard of. This is 1/100th. For example, there are 100 centimeters in every 1 meter. This prefix also applies to other base units as well. So, for example, there are 100 centigrams in 1 gram. There are 100 centibytes in 1 byte. The prefix doesn't change, just the base unit does, depending on what we're measuring. We can always use centi to describe there's 100 of these per one of our usual. After that, we have milli. Okay? M-I-L-L-I. And this is one of our most commonly used ones in things like physics or chemistry. This is 1/1000th. So 1 over 1,000. Okay, again, notice all we're doing, we're just adding another 0 as we go down. We start off with 1 over 10, then 1 over 100, then 1 over 1,000, and we're going to keep on going that way. So there are 1,000 millimeters in 1 meter. In fact, on most standard rulers, I don't have one up here right now, but on most standard rulers where you have a centimeter side, the little lines in between the centimeters, those are millimeters. Okay, so still very small, but big enough for your human eye to still see at this point. Now, once we get to 1,000, we can talk about 1 over 10,000, 1 over 100,000, all that, but it's more useful for us to start adding 3 zeros. So instead of going from 1 over 10,000, we're going to go straight to 1 million. So 1 over a million. We use the term micro. So there are 1 million micrometers in a meter. Believe it or not, yes, we do need to be this precise in measurement sometimes. And it is still possible to do this by hand using specialized equipment, usually some form of caliper. We got 2 more that I want to talk about. Next up will be 1 over a billion. At this point, I don't really want to write all the zeros, so I'm going to write this in scientific notation. I'm going to say 10 to the 9. Similarly, this is 10 to the 6, 10 to the 3, 10 to the 2, 10 to the 1. So 1 over 10 to the 9, aka 1 over a billion, that is going to get the prefix of nano. There are 1 billion nanometers in 1 meter. If you go to my Light 101 video, you'll notice that nano is something that comes up quite a lot, as this is something that's practical for us to measure, for example, visible light wavelengths in, because they're really, really tiny. Of course, when we actually do our math, we need to convert these to our base units. So we had to go from nanometers into meters. So we'll talk about how to do that conversion once we're done talking about these prefixes. Finally, we have 1 over a trillion, 1 over 10 to the 12. This is pico. So, sometimes these are really useful in talking about time, because sometimes things in the universe work on a very fast time scale. There are 1 trillion picoseconds for every single second. So, that covers these. You may be wondering, what is our symbol for all of these? And that's a good question. These are all usually going to be represented with a lowercase letter. So I'll use meters as our base unit here and write out how each of these will be written out. So a decimeter will be written out as dm, both lowercase. Centimeter, lowercase c, followed by an m for meter. Millimeter, lowercase m, followed by another m for meter. Micrometers are a little bit weird. They use a Greek letter instead. They use this thing, okay, mu. Okay, it kind of looks like a love child between an uppercase M and a lowercase u. It's kind of weird looking. But when you see it, that is a micrometer. Nanometers, lowercase n, lowercase m. Picometers, lowercase p, lowercase m. We can use these to quickly be able to describe how big or how small something is. Now, let's go to the other side of things, bigger. Now, believe it or not, in physics, we don't use bigger that often, because we usually don't need to. But sometimes we do use it, and there are multiple applications for talking about really big things. So, we are going to talk about it. Okay? So, we're going this way now in red. Now, let me just double check my list to make sure that I have this right. Yep. Okay, that's what I thought. Just want to double check it. So, instead of there being a certain number of these for every one of our base unit, now there are a certain number of our base units for every one of these. So, let's start off with a decameter. So, there are 10 decameters for every 1 meter. So 10 over 1. It is spelled D-E-K-A. There's actually a bad E. It looks more like a C there. There we go. Deca. Okay. Hopefully that's easy to see. Yeah, it looks easy to see. Cool. So, again, this is 10 to the 1. Our symbol for a decameter is actually a lowercase d and lowercase a, followed by an m. Okay? So, you can think, damn, that's a lot of decameters. Get it? Yeah, pun intended. Maybe. Whatever. All right. Going on from there, okay, to stuff that is a little bit more commonly used. Our next one is 100 of our base units, and that is our hecto, a hectometer. Okay, we're going to be using a lowercase h to represent that, so hm. So 1 hectometer is 100 meters. So for example, at the Olympic Games, the 100-meter dash, they are all running 1 hectometer. Next up, we have 1,000 of our things. So 1,000 of our base units, we use kilo. This one you might have heard of. For example, a kilometer is 1,000 meters and is a pretty good substitution for, say, miles. There's 1.6 kilometers for every 1 mile. So you get about 2/3 roughly of a mile with 1 kilometer. You may have heard this in other things as well. For example, in physics, we actually usually do our math in kilograms instead of grams because that's what our equations are built for. Or in chemistry, you may have to get a sample in kilograms and convert it into grams. So we'll go over how to do that conversion momentarily. Same thing here. At this point, once we hit 1,000, we start jumping in groups of 3. So we go from 10 to the 3 to 10 to the 6, aka a million of. So 1 million of our base unit is going to get the prefix mega. And at this point, we start using capitals. So we would use capital M followed by a lowercase m. Okay, that's actually a really bad lowercase m. Let me redo that. There we go. So a megameter is 1 million meters. Next up, we have a gigameter. You might have heard of this before in digital storage. Or you might have heard of mega in digital storage as well. So for example, a megabyte is 1 million bytes. Giga, again, is 10 to the 9, aka a billion. So Giga, represented with a capital G. So a gigameter is a billion meters. A gigabyte is a billion bytes. And then finally we have tera, which is 1 trillion, or 10 to the 12, of our base unit. We represent that with a capital T. So a terameter would be capital T lowercase m. You've probably heard this more in digital storage via terabytes. So now that we know all of our metric prefixes, we can utilize these to actually start converting stuff. So make sure this is in your notebook or whatever you're writing this down on. I'll give you all a second here without me in frame to block it. That should be enough. So we're going to go ahead and erase this. And we're going to start doing some actual conversions. So we will be right back. Welcome back. So here we have a situation. Let's say I had measured something in millimeters, but I need to be able to do my math in meters. Let's say I'm dealing with some sort of kinematics problem or something like that, and for whatever reason, the actual number was measured in millimeters. In this example, I have 1,126 millimeters, and I'm trying to convert them into meters. Now, I know that there are 1,000 millimeters per meter, but this isn't 1,000. This is 1,126. So I'm not exactly positive off the top of my head how to do this conversion, or at least not by memory. And memorizing how to do these conversions really isn't as effective of a strategy as you may think. So let's do this example and then I'll explain why that is. So instead of memorization, I rely on something called dimensional analysis to do my unit conversions. This is a foolproof strategy that works every single time. And we're going to do a few different examples of dimensional analysis today. So let's start with this one. I have 1,126 millimeters. The first step of any dimensional analysis problem is to put that number down and write it over 1. So 1,126 millimeters. Do not forget your unit. Divided by 1. Put it over 1. Dividing by 1 doesn't change anything about the number, and it makes all the math work a little bit prettier down the road. I'm going to check what unit I'm in right now. I'm in millimeters. I want to be in meters, so I know I'm not done yet. In order to do that conversion, I am going to convert it using a conversion factor. So, the way that looks is like this. The unit that I want to get rid of goes on the opposite side of the fraction. In this case, millimeters I want to get rid of is on top, so it will go down on bottom right here. If I have a direct conversion, I can go directly to what I end up wanting to be in. In this case, I do. I know how many millimeters are in a meter. So, I can write meters right up there. From here, I need to fill in my numbers. My general rule of thumb for this, you can always remember which one is which by remembering that the bigger unit gets the 1. So there is 1 meter for every 1,000 millimeters. Okay, I know millimeters go into meters, so 1 meter for every 1,000 or 10 to the 3 millimeters. Okay, same exact number, just a different way of writing it. At this point, I check to see if I'm in the unit I want to be in. I'm in meters. I want to be in meters. I know that I've set up my problem correctly. So I can cancel out anything that appears on both sides. So millimeters appears on both sides. They cancel out. And I can do my math. All I'm going to do is multiply everything on the top side, the numerator, by everything else. So I only have 2 numbers in the numerator here. I have 1,126 and I have 1. So I'll do that multiplication out. 1,126 times 1 is just itself, 1,126, because anything times 1 is just itself. Then once I do that, I'm going to go down here, and I'm going to do the same thing in my denominator, and my numbers on the bottom. I'm going to do 1 times 10 to the 3, aka 1,000. And I just get 1,000, because anything times 1 is just itself. Finally, to get my final number, I'm going to simplify this fraction, right? I was waiting for that bell for like 5 minutes, and now it decides to ring. Story of my life. So, anyways, my apologies. I'm going to do 1,126 divided by 1,000. So, I'm going to grab a calculator to do that. My calculator is all the way over here, unfortunately. All right, now that I have a calculator, let's do that math out. 1,126 divided by 1,000. And I get an answer of 1.126. I carry over whatever unit I ended in. In that case, this is meters. So my final answer is 1.126 meters. This number I can plug into my math and start doing math with. Now, you may be thinking to yourself, well, Mr. Bell, I already knew there were 1,000 millimeters in a meter. So why couldn't I have just done 1,126 divided by 1,000 in my head and gotten 1.126 anyway? And you're right, that would have worked. But this unit conversion process will work for even things that don't have easy to remember conversions. But more importantly, it's a basic check to make sure you're doing something right. There's a reason that you're supposed to look both ways before you cross the street, or while you wear a seatbelt in your car. Sure, you may be a good enough driver, or you may be very observant. So you may already know there's no cars coming by, or I know I'm not going to get into a car accident. If you think about it like that, though, is it doing that stuff just a waste of energy? See, I had a senior the other day say doing this was a waste of time. And here's why it's not. The one time that checking both ways, or by putting on your seatbelt, that it prevents an accident or prevents serious injury, it's worth it. In my experience, both tutoring and teaching physics, the number one thing that students will do that will get them unnecessary points lost on their assignments is adding or forgetting a zero to an answer. Instead of saying 1.126, they'll say 0.1126. Or they'll say 11.26 or something like that, when the answer is supposed to be 1.126. Then their answer is off by a factor of 10. They have no idea why, and then they get confused. True story about me. I have really bad test anxiety. Right? I suck at tests. I don't like them. They don't like me. So when I was a physics student, I constantly had to develop these kind of strategies to, I call it bell proofing. Another term would be idiot proofing. To make sure that I couldn't make any silly mistakes, any stupid mistakes, to make sure that I was always doing it right. I always did this out, even if I knew what the conversion was already, because I'm double checking that I have the right number. I'm making sure that I'm not relying on my brain, and instead I'm relying on a process that I know for a fact works. It's foolproof. It works every single time. So this, while tedious at times, is important. Let's do another type of conversion. So, welcome back. So, sometimes in physics, you'll be given an equation where the constant requires that you actually specify non-standard units. For example, when I took my first astronomy class, I had to deal with a version of Wien's law that required my wavelengths of light to be in centimeters instead of meters, because it was easier to write out the constant that way. So in this case, I have 1.2 kilometers, and I'm converting it into centimeters. So this is one of those times where we're converting to a non-standard unit. Or a non-base unit, not non-standard. My apologies. So the way that we do this is pretty much the same, but with one extra step. See, I know how many kilometers are in a meter, or vice versa. And I know how many centimeters are in a meter, but I don't know how many centimeters are in a kilometer. I can use meters as my bridge to go from one to the other, and that's exactly what I'm about to do. So, as per usual with dimensional analysis, we start off with our given piece of information, 1.2 kilometers in this case. And we put it over 1. Next up, we are going to see what we can do conversion-wise. I don't have a direct conversion from kilometers going to centimeters. I don't know that one off the top of my head. Right? It's not on my SI unit poster in the back of the classroom. So what is a man to do instead? Well, again, I can realize I know how many meters are in a kilometer. I know how many centimeters are in a meter. So if I use meters as my bridge, I can go from kilometers to centimeters. So instead of converting directly to centimeters, we're going to convert to our base unit, meters, instead. So, unit we want to get rid of, kilometers, goes on bottom. Unit we're converting to, in this case, is meters, because I know my metric prefixes, and I know them in relation to the base unit, and only to the base unit. Bigger unit gets the 1. Kilometers are bigger than meters. There are 1,000 meters per 1 kilometer based off of the prefix. So therefore, this will convert from kilometers to meters. At this point, I check to see if I'm done. I check to see if meters is what I want to end up in. It is not in this case. I want to get to centimeters. So I need an additional conversion factor. Unit I want to get rid of goes on bottom, in this case meters. I do have a direct conversion from meters to centimeters, so I can put centimeters up here. Bigger unit gets to 1. Meters is the bigger unit here. There are 100 centimeters per 1 meter. I check to see if I'm done. Centimeters is what I'm in right now. Centimeters is what I want to get to. I'm good. I can cancel out anything that cancels. So kilometers appears on both top and bottom, so those cancel. Meters appears on both top and bottom, so those cancel. I always find that very satisfying, just going throughout the entire thing. I don't know. I find it something to look forward to. And again, we're just going to do all of our math exactly how we have been. In a calculator, we will do 1.2 times 1,000 times 100. And I get 120,000. In the denominator, I have 1 times 1 times 1. That's just 1. Easy peasy. 120,000 divided by 1 is just 120,000. So my final answer is 120,000. Carry over my unit, in this case centimeters. Put a box around it. You're done. Okay? So I can now prove that there are 120,000 centimeters in 1.2 kilometers. Again, we had to rely on our knowledge of those metric prefixes to be able to do this. Right? Again, I don't know that there's 100,000, I guess. Right? Yeah, I guess there's 100,000 centimeters in every kilometer. I didn't know that before now. This is news to me. So I don't know what this conversion is. So I figure out what do I know in the middle that connects to both. In that case, it was meters. So I convert from kilometers to meters, then to centimeters, and I get my answer. Let's do another example. Okay, so something that we work with very often in physics is velocity. Oftentimes, a car will display velocity or speed in a unit like miles per hour or kilometers per hour, depending on what part of the world you're in. We're using kilometers per hour here for sake of ease. In physics, though, that is not our standard unit that we have to do our math in. We have to convert that to meters per second. This is going to be slightly different than what we've been doing because now there's some division within our unit. It's kilometers per hour. Kilometers divided by hours. It's meters per second. It's meters divided by seconds. This doesn't really change much about our math, but it does change a little bit. So let's set up our dimensional analysis yet again. In this case, I want to go from 30 kilometers per hour to meters per second. So I started by writing our given unit and putting it over 1. The thing that's going to look a little different here is our actual units. See, instead of running kilometers per hour right next to the 30, I'm only going to write kilometers here. Because our problem is already set up for our hours to go on bottom. Because remember, it's 30 kilometers per 1 hour. Now, we have 2 things that we need to convert. You can do this in any order you want. I usually do top one first, then bottom one. So, instead of thinking of it as converting from kilometers per hour to meters per second, think about it as doing one conversion for kilometers to meters, and another conversion from hours to seconds. Let's do that together. Let's start with the top one, kilometers. So, unit I want to get rid of goes on the other side. Kilometers is on top right now, so it will go on bottom down here. I do have a direct conversion from kilometers to meters because we're going to a base unit. So, meters will go right up here. Bigger unit gets to 1. So, this is what we're left with right now. In this case, I'm done in terms of my distance. I'm already in meters. But I'm not in meters per second yet. I'm still in meters per hour. So now I need to convert that time unit. Now, our time unit will actually end up coming out on the bottom. And we want it to because it's per second, right? It's being divided by seconds. It is not seconds up top, it's seconds on bottom. So what we do is we just add another conversion factor, ignore that this has happened here, and start off with hours. Now, I don't know off the top of my head how many hours or how many seconds are in an hour, but I do know how many seconds are in a minute and how many minutes are in an hour. So, again, like our previous problem, I can go from one to the other by using our minutes as our middleman. So, hours are currently on bottom. I want them to be on the opposite side. So, in this case, they go on top. Minutes go on bottom. Bigger unit gets to 1. Hours are bigger than minutes. And just from common sense, I know that there are 60 minutes in an hour. Okay? Hopefully you would know that from, say, kindergarten or whatever you're learning at nowadays. So now I'm in meters per minute, and that's cool. I'm closer to our goal, but I'm not in meters per second yet. So I want to get in per seconds. So I need one more conversion factor. Unit I want to get rid of goes on the opposite side. Minutes on bottom, so minutes go on top. Seconds goes on bottom because that's a direct conversion. Bigger unit gets to 1, and I fill in the rest. I know there are 60 seconds in 1 minute just from common sense, so I'm going to write that in. At this point, I check to see where my distance unit is. It's on top, and it's meters. I check to see where my time unit is in. It's seconds, it's on bottom. So I have meters per second. That's what I want to be in. I'm done. I can cancel everything that cancels. So kilometers cancels, hours cancel, and minutes cancel here. So from here, I'm going to do my math. Everything on top multiplied by each other. 30 times 1,000 times 1 times 1. I get 30,000. Shocking how that works. And that'll be divided by everything on bottom multiplied together. 1 times 60 times 60, which comes out to 3,600. So my final answer in meters per second will be 30,000 divided by 3,600. Let's go ahead and do that. I get a final answer of 8.33, and I carry over my unit. In this case, it is meters per second. So 30 kilometers per hour comes out to be about 8.33 meters per second. Now I can take this velocity and do whatever math I need to do with it. But I wouldn't have been able to do that without my conversion. Let's do one last example just to make sure that we all feel really good about this. So, another useful time to use dimensional analysis is when we're not dealing with the metric system, when we're dealing with some other system of measurement used in some other discipline of science. For example, an AU, an astronomical unit. We use these a lot in astronomy. See, one astronomical unit is the average distance in between Earth and the Sun. Now, that is still a really, really far distance. In fact, it is actually 1.496 times 10 to the 11th meters. I could say, oh yeah, Earth is 1.496 times 10 to the 11 meters away from the Sun, and that would be correct. But it wouldn't really mean much. See, at that point, times 10 to the 11, that number is so big, I actually had to think for a second before I know exactly how big it is. Right? Pop quiz. 10 to the 11, how big is that number? Do you know it off the top of your head? I didn't. It's 100 billion. So this would essentially be 149,600,000,000 meters away from Earth. Or from, yeah, that's the Sun, right? Because of that, when we're talking about distances of other planets that get even larger, we usually default to astronomical units. We default to something that we understand, and then we can rationalize everything else in. So for example, Saturn is on average 9.58 astronomical units away from Earth. Or away from the sun, rather, my bad. I want to know how many meters that is, because again, I need it in meters to do my math. It wasn't measured in meters because it's not practical to measure or discuss those things in meters. Okay? It's easier for me to say, oh yeah, Saturn is 9.58 times further away from the sun than Earth is. Done. Easy. So let's convert this into meters using this known conversion factor, because this is for every 1 AU. Okay? Usually, if you're dealing with a weird conversion factor like this, it'll be given to you at some point, either in your course or on whatever assessment you're dealing with. So, same process as always. We start off with our given, put it over 1. 9.58 AU over 1. We don't need to worry about putting a unit down here because our unit doesn't have any division in it now. So we don't have to worry about that. We check to see, are we in the correct unit? We're in astronomical units. I want to be in meters, so we are not. So AU's on top, goes on bottom because we want to get rid of it. We have a direct conversion that's given to us right here. So meters, we go right on top. Bigger unit gets to 1. Astronomical units are larger than meters. So we have 1.496 times 10 to the 11 right up here. Again, could you memorize this and just know multiply whatever this number is by this number? Sure. But on a test, I'm the kind of person who's going to be like, wait, do I multiply or do I divide? Or what was the number again? Or something like that. This makes sure that you're setting it up right to make sure that you're not accidentally making that mistake. So, in the calculator, I do 9.58 times 1.496 times 10 to the 11. I get 1.433 times 10 to the 12. On the bottom, I have 1 times 1. That's 1. I do 1.433 times 10 to the 12 divided by 1. It's just itself. So my final answer is that Saturn is 1.433 times 10 to the 12 meters, remember your unit, away from the sun. Now, because it's a scientific notation, it may be tempting to say, this number doesn't seem much bigger. In fact, it's actually looking smaller. I went from 1.496 to 1.433. But pay attention to what happened to the exponent. It went from 10 to the 11 to 10 to the 12. So what we've essentially done is we've added an extra 0. So this number is 10 times bigger than this number, which roughly works out with what we had up here. Right? 9.58 is about 10, so we should get an answer that's about 10 times bigger. So with all that being said, hopefully now you feel really comfortable with both the metric system and converting different units in the metric system and understanding why it's important to be able to do that. As always, if you have any questions, leave them in the comments down below. I am happy to answer them. If you have any requests for upcoming videos, please also leave those right in the comments down below. Make sure you absolutely smash that like button, hit subscribe so that you will always know when our next video is up. And as always, thank you for watching. Have a nice day.